Welcome to Hartman Math. Before we get to specifically arithmetic sequences and series, let's review generic sequence and series through our warm-up. Go ahead and pause here, work through our 4 problems, and play when you're ready. All right, number 1, that's pretty tricky. Let's skip that one for a moment. Let's go to number 2, evaluate, where we're just going to kind of crank this out. Substitute in a 1, and then a 2, and then a 3, and then a 4, and a 5. See what we get, add them together. We get 70, but also as we look at that, we get 2 plus 6 plus 12 plus 20 plus 30. So that'll help us with number 1. Here's our a sub n right there. We'll come back to that in a moment. All right, number 3, evaluate. So we substitute in the 1. And we get 0.54, and then we get 0.0054, and then we get 0.000054. So we're going to get 0.54 repeating. Turns out that that's 6 over 11. Again, we'll learn more about that later. Number 4 is a recursive sequence. So we're saying the next term is the 2 previous terms added together. What's the 10th term? Where a sub 0 is 0, a sub 1 is 1. So adding those together, a sub 2 would be 1, and then 1 plus 1 is 2, and then 1 plus 2 is 3, and 3 plus 2 is 5, and so on, and you should get 55. And this turns out to be really the most famous recursive sequence. It goes back to about the 1100s. It's the Fibonacci sequence. It actually has quite a few applications where you see it in patterns in nature. Let's go back to number 1. How could you come up with this without knowing this? So one thing we can look at is differences in our numbers. So if we take a look at our first differences, the difference between our first 2 terms is 4, and then 6, and then 8, and then 10. We see a pattern. But it's not a constant. If it was a constant, it would be going up by the same amount each time. We kind of saw that in lesson 9.1. We're definitely going to see it more in 9.2. It would be an arithmetic sequence or a linear pattern, but no constant. So if we do it again, we'll look at second differences. We get 2, 2, 2. So the second differences are a constant. What it tells us is that our expression is going to be quadratic. So we know it would be something like a sub n is equal to a times n squared plus b times n plus c, something like that pattern. And then what we're going to do is use the first 3 terms to generate equations. So based on the first one, 2 is equal to the first term, so our position is 1. 1 squared, 1, we get a plus b plus c. And then 6, now we're talking about the second term position, 2, n is 2. 2 squared is 4. 4a plus 2b plus c. And then 12 is equal to 9a plus 3b plus c. Now we can solve that system. And I might recommend at this point that we do it with matrices and a graphing calculator and inverses. You can do it pretty quickly. But either way, you're going to find out that a is 1, b is 1, and c is 0. And that leads to 1n squared plus 1n plus 0. There it is. This is lesson 9.2, arithmetic sequences and partial sums. So the definition of an arithmetic sequence, we've got our sequence where the difference between the consecutive terms are the same. So if we subtract the second minus the first, or the 8th minus the 7th, or the 100th minus the 99th, we're going to get the same number each time, and that will be the common difference, designated as D, common difference. So the formula for finding a term later on in the sequence is the generic a sub n is the first term, a sub 1, plus n minus 1, where n is the position that we're looking for, times that common difference of d. Find a formula for the nth term of a sequence whose common difference is -7 and whose first term is 19. This should be very easy, as the two things that we're looking for are known. So the first term, 19, the common difference, -7. Careful there. We're going to want to show that with parentheses there, because otherwise it would mean subtract 7. We want it to mean times the d, so times -7, so we'll use parentheses. And then if you're doing this in WebAssign, it's probably going to accept it like that. I typically like to simplify, distribute, and combine like terms. And get that. WebAssign should accept either answer. Checkpoint. Go ahead and pause here as you find the formula for an arithmetic sequence where you know the common difference is 17 and you know the 8th term of 200. Don't work it backwards just by writing it out. Use algebra. All right, the 8th term should lead to the first term by the formula. So we'll start there. The 8th term is the first term, which is unknown, plus 8 minus 1 times 17. We know that's going to equal 200. And so we're going to solve for a sub 1. We get a sub 1 is 81. And then substitute that back in with the a sub 1 and the d that we know. Distribute, combine like terms, and we get a sub n is 17n plus 64. Example number 3, find the third term of an arithmetic sequence where the third term is 29 and the 10th term is 71. Find a formula for the nth term. So we don't know a sub 1, we don't know d. Each of the ones that we've been told is going to generate an equation with two variables. So we're going to create a system here. So I like to start with the one with the higher n value. It doesn't matter either way. It tends to work out easier this way. So if we do that, we get this part here. And we know that we're going to simplify it, so that's 9d, and we know that's going to equal 71. And then we're going to do something similar for the third term being 29. So 29 equals a sub 1 plus 2d. We're going to eliminate the a sub 1s by subtracting the two equations in columns. So 42 equals 7d, and that leads to d, our common difference, being 6. And if we substitute that back into either one of these, we can find a sub 1. So a sub 1 is 17. So now we'll go back into the formula, distribute and combine like terms. A sub n equals 6n plus 11. The formula, if we're looking for the sum of a finite, so the first 13 terms, the first 130 terms, it has to be finite, is s sub n, and is how many terms we're adding up, is the number of terms divided by 2 times the first term plus the last term. So it is possible that that a sub n formula we're just working with might be relevant again in terms of arithmetic. Okay? This formula really came from Carl Friedrich Gauss, and the legend is when he was 7 years old, the students in his class were given the problem to add up the first 100 whole numbers. He came up with it first, and he did it based on a pattern. And he recognized this. Notice that if he added the first and the last, the second and the second to last, and the third to last, he kept getting the same sum. And if, since there's 50 pairs of numbers, he just multiplied that sum by 50, got his answer. So let's use that to find the 102nd partial sum, meaning the sum of the first 102. If we added this and this and this and this and 98 more, what would we get? Okay, so for our formula, we need to know how many terms we're adding up. We do. What's the first? And then what's the last? We don't quite know that yet, so we're going to go after the last. We're going to use our a sub n formula to find the last term. So a sub 102 is equal to first term plus 102 minus 1 times the common difference of -6. You make that calculation, you get -305 for the last term. So now we're going to do capital S sub 102 is equal to 102 divided by 2 times first plus last. If we do that calculation, we get a sum of negative 204. Checkpoint. Find the sum. Again, using algebra. Pause here until you're ready. In this problem, the one thing we don't know is n. We don't know how many terms are being added up. So we're going to need to find that. And again, we're going to use the a sub n formula. We're going to focus on the 91 because we need to know the position that the 91 is in. What's the n that goes with 91? So 91 is equal to a sub 1 plus the unknown n minus 1 times the common difference of 4. And that's going to lead us to finding that n is 23. And now we can do s sub 23. 23 divided by 2 times first plus last. And we get our final answer of 1081. Let's see if we can evaluate a sum that's already in sigma notation. So the sigma means find the sum. If our expression here is linear, kind of an mx plus b situation, that's going to lead to an arithmetic series. So we can use this arithmetic series formula. So first thing we would do is say s sub what? Well, if we start our count at 2 and finish at 15, how many terms are we going to be adding up? It's 14. So s sub 14 is equal to 14 divided by 2 times first. Now the first is what we're going to get by plugging in a 2, the lower limit of summation. So 5 times 2 minus 7 is going to give us 3. 3 plus, and then the last one's going to be substituting at 15. 5 times 15 minus 7, which is 68. Do the calculation from there. We get the sum. That's it for today. See you next time.